And so that statement, every action has an equal and opposite reaction, is like true, but also a bit misleading. And there's a few things that Newton's third law says that are like more detailed than this. So um, by saying every action has a reaction is really saying that forces come in pairs. So like an extension of that is to say like I don't have to look everywhere in the universe to know that there is always an even number of forces in the universe at all times. There's no one force that goes without reaction. And so action and reaction are like the names of the forces according to Newton's third law. And so the action reaction pairs uh, have the following like properties. So we say they are always, and then there's a short list of things that all action reaction pairs are. They are always equal in magnitude. And you saw that in your lab. The forces are always the same size. If the first cart pushed with 10 newtons, the second cart pushed back with 10 newtons. So that's what equal in magnitude means, same number of newtons. Okay. The other thing you saw in the lab is that they're always opposite in direction. And so you knew that kind of from the start. So when those carts collide, they are going to push each other in the opposite direction. One of the minor points is that they are always simultaneous, meaning they always happen at the same time. This idea of like action and reaction tends to make people think that the action happens first and then the reaction happens, but in reality, they're always the same time. And you saw that like when one graph started to spike up, the other one started to spike down. And then the last one, which is kind of the key to all of this, is they're always the same type of force. And so if there's a gravity action, there's a gravity reaction and so forth. So, if you like see all the types of forces over here, any action reaction pair has to be the same type of force, but on opposite or different objects. And so I'm going to try and squeeze in uh, an example or two. If you like drive around New England over the summer at night and you're going like a long distance, especially on a highway, you are going to kill a lot of bugs because they're flying around everywhere and you're just like driving through them. So we're going to imagine that the action force is the windshield of your car hits a bug. And so every time like the bug is just sitting there and you're flying through down the highway, your windshield hits the bug, and that's it for the bug. The reaction is that at the same time, the bug is hitting the windshield. And that can be kind of weird, right? Like or maybe it makes sense. When you hit the bug, there's a force that your windshield exerts on the bug, it kills the bug. There's also a force that the bug exerts on your windshield, right? The bug hits your windshield with the same force that it just got hit, but nothing happens to the windshield because the windshield is attached to the car. It's much heavier, it's much sturdier than the bug. So these forces have the same amount or magnitude, but they have different effects on things. And so that's kind of the key to Newton's third law is that no matter what you did to the carts, different masses, different speeds, those forces were always the same, but the results were different. My final example has to do with gravity. And so the action force, the reason that I'm sitting here or standing here on the ground is that there's the force of Earth's gravity on me, and that Earth's gravity pulls me down toward it. Newton's third law says there has to be another force. It has to fit all of these criteria. And so the reaction force would be my gravity on Earth. Meaning, if Earth is pulling me down toward the center of the planet, I'm actually pulling Earth up with my force of gravity. So I produce a force of gravity on the Earth, and we are pulling on one another with equal magnitudes, opposite in direction at the same time, and that's that. So Newton's third law gets very repetitive, and that's kind of the point of like when you're learning it, you want it to sound repetitive. Um, that when we talk about action reaction forces, they're different objects pushing, different objects get affected, but it's always like equal magnitude and the same time. So that's Newton's third law.